Hello viewers, welcome to today's tutorial video. Today we'll be solving a momentum question which we just took from a tutorial sheet. As you can see here, we've been provided with answers. Therefore, what we need to do is to just try and solve the question and compare our answers to what we've been given. Okay, so whenever you're solving a physics question, what you need to do is you need to correct the information or the necessary data from the question which you're going to use when solving. Okay, so we're going to say our data. Okay, so we've been given the initial velocity of ball 1, which is 6 meters per second, the initial velocity of the second ball, which is 0 meters per second, and we've been given the angle which the striking ball makes, which is just 25. Okay, and they're telling us to find the final velocity v1 prime. I'm going to call it v1 prime for our first ball, which we do not have. For our second ball, I'm going to call it v2 prime, which we do not have, and the angle also which the struck ball makes, I'm going to call it theta, so we do not have this. Okay, so this is the data that we've been given. As you can see, we have 3 unknowns. Therefore, we need 3 equations in order to handle such a question. Therefore, let's visualize this question in form of a free body diagram. So what we're going to do is we're going to say ball 1, which was moving at 6 meters per second, struck another ball which was at rest. Okay, so this was moving at 6 meters per second, while this one was at rest, 0 meters per second. After the collision, let me draw this nicely. After the collision, okay, all right. After the collision, we are told that ball 1 went off at an angle above its original direction of motion, meaning it went this way. And it is obvious that ball 1, the second ball also went off at an angle which is opposite to the angle of the first ball. Right. Okay. Let me just try to put the necessary information on the diagram. Okay. I've been given this angle to be 25 for the first ball. For the second ball, we do not have. We'll label it theta. Okay, what we need to put in mind is after the collision, there was motion in the y-axis. Therefore, we need to find the components in the y-axis of the final velocity of ball 1 and ball 2. Therefore, we're going to do this. Going to do this and label it the y component of ball 1, and we're going to label this as the y component of the second ball. Okay, so we know that the y component just given by v1 sine theta. For the second ball, we're going to label it v2 sine theta, since this is our v2. Okay, and this is our v1. Okay, and we're trying to find this component and that component. And then in the x-axis as well, we can try to put x comp here. On the second ball, you can put it here as well. So this is going to be given by v1 cos theta, and then this for the second ball, it's going to be given by v2 cos theta. Okay, so we've collected or inserted all the important data on the diagram. What we need is to solve the question now. Okay, let's clear out space and try to solve this question. Okay, it's a tough question and time taking, but it's manageable. All right. Okay, we can even remove the diagram so that we create space. Okay, so what we need to do is we need to conserve momentum in the x-axis. Right? So I'm going to say momentum initial must equal to momentum final, and you know that momentum just given by m1 v1 plus m2 v2 is equal to m1. Now on the velocity, we're not going to put v1 final, we're going to put the x component of v1, which is v1 cos theta. We're going to do the same for the second ball, which is m2 v2 final cos theta. Right, so the final velocities, I'm going to represent them by a prime to represent final. Okay, and in the question we've been told that the mass was the same for the two balls. The mass was the same, therefore we can cancel out the masses in order to simplify our equation or to make our life easy. So I'm going to say what's going to remain is going to be v1 plus v2 is equal to v1 prime cos theta plus v2 prime cos theta. All right, so from this equation we are going to call it equation number one. Okay, all right, so what we need to do here is we need to solve for cos theta since we do not have cos theta. After solving for cos theta, we're going to conserve momentum also in the y-axis and solve for sin theta. After doing that, we're going to square cos theta and sin theta and combine them and equate them to 1, since we know from the trig identity that cos squared theta plus sin squared theta is equal to 1. So this is what we're going to use in order to handle this question. Okay, so let's proceed. If you do not understand what I'm saying, stick around and watch what I'll be doing. Okay, all right, so from our equation 1 we can simplify it further and say v1 is equal to, since the initial velocity for the second ball was 0, v1 is equal to v1 final cos theta plus v2 final cos theta. Okay, so from this equation, let's try to solve for cos theta. Before we forget, we solve for cos theta, this unknown angle. So if we manipulate this, we're going to find that cos theta is going to equal to v1 minus v1 final cos theta. So this is our manipulated equation 1. Okay, or simplified equation 1. So this is our equation 1. So we need to keep this equation because we're going to use it as we go on in this video. Right. Okay, so let's clear space on top and solve for momentum or conserve momentum in the y-axis as well. Okay. All right, so I'm going to say in the y-axis m1 v1 plus m2 v2 is equal to m1. For the final velocity of the first ball, we're going to put the y component of that velocity, which is just v1 final sine theta, plus for the second ball, we know that it went below the y-axis, or in the negative direction of the y-axis. Therefore, we're going to put a negative here. We're going to say negative m2 v2 sine theta. Okay, so initially we know that there was no motion in the y-axis. Therefore, this whole thing, we're going to cancel it. So on this side, we're going to have 0. 0 is equal to m1 v1 final. Sorry, I wanted to say cos. This time it's sine. Okay, it's going to be m1 v1 sine theta minus m2 v2 sine theta. Okay, so when m2 v2 sine theta goes on the other side of the equal sign, or it crosses the equal sign, it's going to be m1 v1 final sine theta is equal to m2 v2 sine theta. At this point, we can cancel the masses since we know that they are the same, and therefore our equation is going to be simplified to v1 prime sine theta is equal to v2 sine theta. So we're going to label this as our equation 2. And we shouldn't forget that we also need to solve for sine, the unknown angle in this equation 2. Okay. Alright. So when you solve for sine theta, our equation 2 is going to be v2 sine theta is equal to v1 final sine theta. We're going to divide by v2, leaving this side v2. Okay, so this and this goes. Therefore, our sine is going to be sine theta is equal to v1 final sine theta divided by our v2. So this is our sine theta. Like I said earlier, we need to combine these two, sine theta and cos theta. Okay, so that we use the trigonometric identity to find for one of the velocities. Okay. Okay, so from our previous equation, equation 1, we found out that our cos theta was equal to v1 initial minus v1 final cos theta divided by our v2. And from the second equation, which we just derived here, our sine was given by sine theta, it was equal to v1 final sine theta divided by v2. So at this point in time, we're going to square the sine theta. Square this, meaning also going to square this. Okay, even this side we do the same. Square it, Okay, all right. Okay, so we're going to combine the two using the trigonometric identity, which is cos squared theta plus sine squared theta is equal to 1. Okay, all right. So we're going to say our v1 minus v1 cos theta squared divided by our v2 plus our v1 sine theta divided by our v2, square the whole thing, okay, is equal to 1. So using this equation which we formed, we can solve for one of the missing velocities, but we need to put in mind that we have 3 unknowns, meaning we also need a third equation. How are we going to find that third equation? We need to go back to our question again and check and see if the collision was elastic. Okay, so the question was saying after an elastic collision, meaning kinetic energy was conserved. Therefore, we're going to say kinetic energy initial must equal to kinetic energy final, meaning in this collision energy was conserved. Therefore, we can use this equation for kinetic energy initial equal to kinetic energy final to solve for these missing velocities, because only using this equation which is on top here, which we just derived, is not enough. Okay, so let's try to manipulate this equation and simplify it a bit. Okay, all right, so here is going to be v1 minus v1 final squared cos theta squared, everything divided by our v2 squared, plus when you square this side where there is sine, we're going to have our v1 final squared sine squared theta divided by our v2 squared is equal to 1. Right, let's simplify this equation further. Okay, so that we expand the cos theta. Right, okay, all right, so we can expand this. When we expand v1 minus v1 final cos theta squared, this is going to give us v1 squared minus 2v1 multiplied by v1 final cos theta, okay, plus v2 squared cos squared theta. Okay, so when you expand this thing, this part here is going to give us this. Okay, all right, so I'm going to keep this and replace it here. Okay, so we're going to say v1 squared minus 2v1 initial. Must put in mind that this is just v1 initial because it doesn't have a prime, multiplied by our v1 final cos theta plus our v1 final squared cos squared theta, everything divided by our v2 squared plus our v1 final squared sine squared theta divided by our v2 squared, which is equal to 1. Alright. Okay, so we can try to get rid of the v2 on the denominator by multiplying the whole equation by v2 squared. Okay, so we're going to multiply this whole equation. Okay, this whole equation by v2 squared. So when you multiply by v2, we're going to get v1 squared minus 2v1 open bracket v1 prime, which is v1 final cos theta plus v1 final squared cos squared theta plus v1 final squared sine theta is equal to our v2. Okay, our v2. Okay, so from the look of things, we can see that this equation contains the three unknowns. We have our v1 final, which we do not have, our cos theta, okay, our cos theta, our cos, in this case we have, and our v2 we do not have. So it contains two unknown, our v2 and our v1, meaning there's no way we can find these values, these two missing values, using this equation. Therefore, what should we do? What we need to do here is we need to use the elastic collision part of the equation, meaning kinetic energy is conserved. Okay, so I'm going to keep this equation. I'm going to keep it because we need it. Okay, so we're going to say KE initial must equal to KE final, which is just given by half m1 v1 squared plus half m2 v2 squared must equal to half m1 v1 final squared plus half of m2 v2 squared. So since the masses are same, we can cancel out the masses, this and that and that and that goes. Therefore our equation will be v1 squared plus our v2 squared is equal to our v1 final squared plus our v2 squared. Alright, since we know that the second ball was initially at rest, meaning this value, this v2 initial, just 0, we're going to put 0 here and simplify our equation further. Alright, so going to clear out this part. Okay, I'm going to clear out this part. Alright, so our equation is going to be v1 squared is equal to v1 final squared plus v2 squared. Alright, so this is our third equation now. Third equation. Okay, so what can we do with this third equation we've derived here? Okay, our third equation is going to help us to find for the final velocity of ball 1. Since here we've been given that, or just find out that v2 squared is equal to this thing, this whole part. This whole part is just v2 squared. Therefore, we're going to get this and replace it on v2. We know that our v1 squared, we have this value. Therefore, we'll only be solving for v1. Therefore, let's get this value and put it on v2 and find for one of the velocities. Okay. Alright. So we are going to say, okay, we are going to say our v1 squared is equal to our v1 final squared plus v2. Now on v2 we're going to put this, which is just v1 squared minus 2 v1 initial multiplied by our v1 final cos theta plus our v2, plus our v1, that's v1 not v2. Okay, plus our v1, okay, plus our v1 final squared cos squared theta plus our v1 final squared sine squared theta. Alright. Okay, so whenever you're solving a physics equation, guys, what you need to do is you need to deal with the equations first. Do not plug in the values yet. Solve for the missing variable, one of the missing variable, and replace the values after simplifying the equation, because in that way you can never make a lot of mistakes. Okay, so from the look of things, you know that this is our v1 initial, and this is our v1 initial, and this is our v1 initial. Therefore, this and this can cancel. Therefore, our equation is going to be 0 is equal to our v1 final squared minus 2 our v1 initial multiplied by our v1 final cos theta plus our v1 final squared cos squared theta plus our v1 final squared sine squared theta. Alright, at this point now we can plug in the values. Okay, we can plug in the values here. Alright, okay, so we're going to say 0 is equal to v1 final squared, we do not have this, minus 2 multiplied, what was our initial velocity for ball 1? It was 6. Okay, it was 6. So we're going to put 6 multiplied by our V1 final. We do not have this. Okay, so we're going to leave it. Multiplied by cos. We know that our cos was 25, the angle. 25 plus our V2 final. We do not have. Our V1 final, sorry. Our V1 final squared. This is what we're looking for. Multiplied by cos. Okay, so we're going to say, just a minute, is a square, there's a power there, power 2, meaning we're squaring this. So we're going to say, open bracket, cos 25 squared plus our V1 final, this is what we're looking for, multiplied by our sine 25, okay, squared. All right. Okay, so equation is going to be 0 is equal to our V1 final squared. When we punch in this, it's giving me, okay, let's try to punch in this. Okay. Alright. When I punch in this, what I'm getting is, alright, when I punch in cos 25, okay. Alright, it's giving me, okay, it's giving me 0.8. Alright, so this is going to be, so it's giving me 10, yeah, 2 by 6 by cos 25. Okay, so this part is, it's giving me negative 10.8756. Okay, 5, all right, 5693. Okay, plus when you punch in cos 25 squared, cos 25 squared, right, cos 25 squared is giving me 0.82139. okay, so there are a lot of decimal places to keep here, so it's giving me 0.82139. okay, V1 squared. When you punch in sine 25 squared, what are you getting? Okay, we're getting we're getting 0.1786. So when you punch in this, we're getting 0.178, sorry, yeah, we're getting 0.178. okay, so we're getting 0.1786 V1 squared. v1 squared. Okay, so we know that we can add these two. These can be added to simplify our equation here. So we're going to say 0 is equal to v1 squared minus 10.875693. When you add these two, we're getting, okay, when you add these two, what are we getting? What are we getting? Okay, we're getting 1.9999999. Okay, so we're getting 1.999 up to infinity. Okay, so 1.99 v1 squared. All right, let's clear space on top here. We clear space so that we solve for v1 final. Our work is becoming easier. Okay, all right. Okay, okay, so this is going to be 0 is equal to v1 squared minus 10.875693 v1 plus, sorry, I didn't indicate v1 here. Yeah, it was v1 plus 1.999k v1 squared. Okay, so at this point in time, sorry, remember earlier that we had cancelled out this v1 squared. It cancelled out with the other one which was on this side, so we no longer have this. So our equation is 0 is equal to negative 10.875693 v1 plus 1.999 v1 squared. Okay, so we have this equation. What are we going to do here in order to solve this equation? Okay, so we have like terms. We have v1 and v1. So we can say 0 is equal to negative, okay, we're going to open bracket, negative 10.875693 plus 1.999 v1 close bracket v1. We just did a factorization here, just factorized v1. Therefore, our v1 is going to be v1 is equal to 0 or 0 is equal to negative 10.875693 plus 1.999 v1. Okay, so in actual sense, we know that the final velocity for v1 cannot be 0. Therefore, we're going to forget about v1, this part. v1 cannot equal 0. Therefore, we're going to neglect this part or ignore this part. So we're going to say, we're going to solve this equation for v1. So we're going to say 1.999 v1 is equal to, when the negative 10.8 crosses the equal sign, it's going to be positive. It's going to be 10.875693 693 divided by 1.999, even this side 1.999. Okay, so when we divide this, what are we getting for V1? Okay, all right, so our final answer is, okay, let's clear out space here. Okay, all right. Okay, so guys, this question was a little bit involving, but it was manageable. You just have to know what you're doing. It's simple, guys. It's just a long question. Therefore, when we divide this and that will go. Therefore, our V1 is going to be, okay, it has given me 5.4377, which is just V1 is equal to 5.44 meters per second. So this was our final velocity for ball 1. Okay, at this point we can use our equations and solve for V2 as well. Okay, remember our third equation was V1 squared equal to V1 final squared plus V2 squared. So we're going to replace on V1, our initial velocity for ball 1 was 6, squared is equal to our V1, just got 5.4, so I'm going to put this 5.44 squared plus our V2 squared. So this is going to give us 36 is equal to, when we square the 5.44, getting 29.568. Okay, 29.568. Okay, 568 plus our V2. When you solve for V2 squared is equal to 36 minus 29.568. Our V2 squared is going to be, okay, minus 36. Okay, it's giving us 6.42. Right, it's giving us 6.4, yeah, 6.43, sorry, 42, 6.42. Okay, so when you take square root of this, cancel out the power, our V2 is going to be 2.53 meters per second. Okay, this is our final velocity for the second ball, and it makes sense because initially it was at less, so it gained velocity. After it started moving, its velocity was increasing, and for our ball 1, our first ball, the velocity was decreasing, which is 5.44. What else are we supposed to find? What's remaining is the angle. So which formula can we use to find the angle? We can either use our equation 1 or equation 2. Alright, I'm sure you guys recall very well or remember that initially we solved for sine theta. Sine theta was equal to V1 final sine 25. This was sine theta, or let's do this to avoid the confusion. It's going to be v1 final sine theta divided by our v2. I hope you remember this equation, guys. This was our second equation, which we just derived from momentum. The momentum we conserved in the y-axis. Therefore, we have this theta, it was 25. V2 we have and V1 we have. So here it's just a matter of replacing and finding for theta. Therefore, we're going to say our sine theta is equal to, okay, our sine theta is equal to, what was our final velocity for ball 1? We've been given it. We found out that it was 5.44 multiplied by sine 25 divided by our V2 was 2.53. Okay, so when we punch in this, our sine theta is going to be our sine theta is going to be 0.9087. Okay, solving for theta, we're going to take the sine inverse of 0.9087. So theta is equal to sine inverse of 0.9087. Okay, so our angle is going to be, right, when we take the inverse of 0.9087, okay, our value, our angle is going to be, it has given me theta is equal to 65.43 degrees. Okay, since our answer was presented in 3 significant figures, therefore our angle is going to equal to 65.4 degrees. Okay, so this is our final velocity, our final angle, and our final velocity for ball 1, we found that it was 5.44 meters per second. For the second ball, it was 2.53 meters per second. Okay, alright, so we can check that our answers are just the same as these ones we've been provided with this question or tutorial sheet question. Okay, so guys, we've reached to the end of the tutorial. It's the end of the tutorial. It has been the Inorganic Chemistry Tutor, guys. Make sure that you subscribe so that you don't miss any new videos that will be posting. Videos in the 4 courses that we do, which is chemistry, physics, biology, and mathematics. It has been the Inorganic Chemistry Tutor. Once again, I say bye bye, guys.